Let's take a look at exponential transformations. What this is about is what happens when we shift the exponential a certain direction, like up or down, left or right. Let's see what the function looks like. Let's take a look at the parent function. We always start with the simplest one right here. This one, you will often see it written as just y equals 2 raised to the x power. Well, that function is graphed in blue right here. As we often see, it's an exponential growth. But when we multiply it by a negative number, like -1 or -2, any negative number, what happens to the graph then is it flips downward. It actually goes down below the x-axis. That's why we call it reflecting across the x-axis. So the domain would be the same for this. It goes left forever and right forever, so it would be all real numbers. But the range here changes. See, all of the numbers for the range are in the negative, never positive, and never quite reaches 0 either. So in this case, we would describe the range as all numbers smaller than 0. Let's take a look at the situation. Here again we have the parent function, 2 to the x power. But when we multiply the exponent where the variable is by a -1, by a negative number, any negative number, what it does is it reflects this graph, it flips it to the left across the y-axis. So when the negative is in the exponent position, it reflects everything across the y-axis to the left. This does not change the domain or range at all. The domain is still all real numbers, left and right, and the range is still all numbers bigger than 0. Let's take a look at how we can affect the graph by widening it or making it more narrow. Let's start with this parent function here, the one we always use, 2 raised to the x power. And remember, there's an invisible times 1 right there. Well, if we multiply it by 3, a number larger than 1, it makes the graph narrower. Okay? Now what happens if we take the parent function, 2 to the x power, but we multiply it by a number smaller than 1, but bigger than 0. So it's between 0 and 1. What happens, it widens the graph. See how the original is here, and then now it's kind of flattening out, so it's widening it. That's the thing you need to recognize, is the number that you multiply the function with affects how narrow or wide it goes. Okay, when you have an exponential function where the base is a number bigger than 1, you have an exponential growth, increasing. But when the base of the exponent is a fraction between 0 and 1, it means you have a decreasing function. So it's an exponential decay. Let's take a look at a situation when we are shifting up and down. Again, here's the parent function, 2 to the x. But when we add a +3 at the end, what it does is it shifts the graph up 3 units. 1, 2, 3. When we minus 3 at the end, the parent function shifts down 3. 1, 2, and 3. When we shift up and down, the domain does not change because the left and right curve still goes forever. So it's still all real numbers. However, what we did change though is the range did change. When we shift this graph up 3, the range is no longer all numbers bigger than 0. It's actually all numbers bigger than 3, because this red graph here keeps getting really close to the number 3, but it never quite touches it. Same thing here. When we shift down 3, this curve now starts to approach -3. It never quite reaches -3. So the range is now all numbers higher than -3 rather than all numbers higher than 0. Here's how we can get an exponential function to shift left or right. Here's the parent function, which is in orange. If you want it to shift left or right, you have to add or subtract a number with the exponent, not at the end to the right here, but with the exponent x. And this is kind of backwards. If you minus 3 to the exponent, the graph shifts right. If you add 3 to the exponent, the graph shifts left 3 units. All right, it's just kind of backwards. But notice that the shifting left to right, you have to add the number to the exponent, not at the end. Here is a summary of all the transformations. If you look at, if there's a number that's being added or subtracted at the end that causes a shift to go up or down. If the exponent is being added a number positive, then it's shifting left. If it's being added a negative number, it's shifting right. If it's being multiplied by a negative, it's going to flip to left. The number to the left of the base, if it's negative, it's going to flip down. Any number, the number itself, if it's greater than 1, it's going to get narrower. But if the number is between 0 and 1, a fraction between 0 and 1, then it's going to widen. Now the base itself, the number inside the parentheses, if it's bigger than 1, then it's increasing, so it's exponential growth. If it's a fraction between 0 and 1, it's decreasing. It's called exponential decay. That's it.